Alright, having a little trouble doing this one error-free. I forgot to turn on the mic on the take that I did perfectly, and now I'm doing it again because I made a dumb error in the second time through. Alright, we've got this subsidy problem. There's our demand. There's our supply function. And we're asked to analyze the deadweight loss associated with a $120 a unit subsidy. So we're going to analyze the market equilibrium. Then we're going to analyze the market equilibrium without a subsidy. Then we'll analyze the market equilibrium with a subsidy. Then we'll graph this problem. Then we'll, that's a 4, believe it or not, we'll conduct our welfare analysis, which is just going to be to calculate deadweight loss in this case. Let's get started. So the market analysis, we just have quantity demanded equals quantity supplied, and that's just 50 minus P over 2 equals 5 halves P plus 5, because there's no tax, no subsidy. What buyers pay is the same as what sellers receive. I subtract 5 from both sides. I add P over 2 to both sides. 3P equals 45. P is equal to 15. And I can plug 15 back into either function to get Q is equal to 42.5. That was the without subsidy case. But let's do the market with a subsidy. And here we still are going to be in a world where quantity demanded and quantity supplied is our equilibrium condition, and demand looks a lot like it did before. It looks exactly like it did before. If I could write and talk at the same time, it would be better. 50 minus P over 2. But now, buyers aren't getting P, they're getting, sellers aren't getting P, they're getting P plus 1.2 or 6/5 dollars. So now they're going to be reacting to 5 halves times not the price, but the price. P is what buyers pay. Government's kicking in 1.2. We're going to call that 6/5. Same thing. And with the rest of the supply is the same. So now we can solve this. Five halves times 6/5 is just 3. Now I'm going to subtract 8 from both sides and add P over 2 to both sides, and I get 3P equals 42. That's a 2. Boy, have these slips of the pens get late in the afternoon for me. P is 14, and Q is 43. I can get that either by plugging 14 into the demand expression, P equals 14, or I can plug, while I have it expressed this way, I can plug P equals 14 here, because then 14 plus 1.2 is 15.2, and I'm okay. All right, now we turn to our graphical analysis and the deadweight loss calculation. All right, the easiest way to graph things is to get the inverse functions. And the inverse demand curve is, demand was Q equals 50 minus P over 2, so we move 50 to the other side, Q, and we swap P and Q, I guess, and multiply through by 2 to get the inverse demand function is P equals 100 minus 2Q. Pretty steep. And then the inverse supply function, we have the supply function Q equals 5/2 P plus 5. So that means the inverse supply function, I guess I should keep going with my subscripts for another little while. Inverse supply function is -2 plus 2/5 QS. All right, so that's our inverse functions, and that makes it a little bit easier to map in price quantity space. So our demand curve looks like this. Slope of -2, so it would intersect at 50. And the supply curve is a little bit funky looking in this case. It has enters the first quadrant at +5 on the quantity. That's pretty flat. All right, and we know from our calculations, algebraic calculations, that the initial market clearing price, this is 100. That looks like 1,000 because my little dot is not solid there. The initial equilibrium price was 15. Quantity was 42.5. And that's the market without a subsidy. I'm going to change colors for the subsidy case. Move to this orange. And here, I'm going to just blow it up, even though I'm not going to be drawing to scale. We're looking for the quantity where buyers pay, sellers receive, I should say, 120 more than what buyers pay. And we calculated that out. So sellers are going to end up receiving $15.20 a unit here. And buyers are going to be paying just 14, and that subsidy kicks this market to 43. The deadweight loss is this triangle right here. This sheets of plywood past 42.5 costs sellers more than valuers value it. We add up that excess of costs over value, and we get this deadweight loss. The calculation is when we had these were millions per year. Oh, this wasn't the plywood. This, I don't think I've specified a product. But anyway, deadweight loss is equal to the area of this triangle, so it's 1/2 times 1.2 times 0.5 million, which is equal to 300,000. That's a K there for 1,000. I knew I was running out of room per year. Just a quick point, notice the incidence of the subsidy, even though we gave it to the, who did we subsidize? We gave it to the sellers. Notice that because the demand curve was so much less elastic than the supply curve, that subsidy accrued largely to the buyers. There, the price paid went from 15 to 14, so the buyers captured $1 of that 120 subsidy. The buyers only captured 20 cents of that $1.20 subsidy.